Hello everyone and welcome to STEM School. Today is the part 2 video on the topic of ratios, where we'll be doing some GCSE exam questions to help with your revision. So check out my part 1 video for more clarification and the basics of ratios. So when it comes to exam questions on ratios, they tend to be a big step up from the examples from your notes, and they do vary a lot. There's no distinctive pattern here. So the key is to do just as many questions as you can for practice. So what we'll do is we'll start off with the first question. The first question is saying that the value of y is 20% more than the value of x, and we have to circle the ratio xy, so we've got a multiple choice question. So we're starting off with a fairly simple question. So what we can do, right, is write an equation that depicts both the variables x, y, and you're basically going to say the relationship between them. So what we can say is that y, from the information given, we can say that y is equal to 1.2x, right? So the 1.2 here is 120% written in decimal form because we're told it's 20% more than the value of x. So what we can do is sub this into the ratio xy. So x colon, and we can sub in y for 1.2x, right? And this can be broken down into 1 colon 1.2. So that's the simplified ratio. So from the left hand side, the x variable, we know the left hand side number will be the smallest number. So we can immediately cross out this option and this option. So we've got two options left, okay? So what we can do is just multiply different numbers to see if we can figure out which one of the options it is. So say if we multiplied both sides by 5, what do we get? We have 1 times 5 is 5, and 1.2 times 5 is 6. So the correct answer is 5, 6. Now let's move on to question 2, and this is a fairly common question for ratios. So we've been told that b is 2/3 of c, and that 5a is equal to 4c. And what we've been asked is to work out the ratio of a, b and c. And you have to give your final answer in the simplest form where a, b and c are integers. So the key word here is integers, which means that we don't want our final ratio to include fractions. And then when it comes to the simplest form, we have to basically find common factors and simplify the ratio so it's as small as possible. So when it comes to questions like this, we'll get statements, and this is just a clue that tells you can write each of these letters as an expression of c, because c is common to both statements, okay? So let's start with the first statement. So we've already been told that b is equal to 2/3 of c. So what we have here is a letter in an expression including c. So that's fine. So let's move on to the second one. We've got 5a is equal to 4c. So now, just like before, we want an expression for a including c. So we can write a on one side, and it will be a is equal to 4/5 of c. Now at this stage, what we can do is write the ratio a, b and c in terms of expressions of each of the different letters, okay? So for a, we've got 4/5. Then for b, we've got 2/3. Then for c, we just have 1. Now we don't want fractions, we want integers, so we have to convert this, okay? So we can put this over a common denominator. So the common denominator for 5 and 3 would be 15. So to convert 4/5 to a common denominator of 15, you multiply it by 3/3. So 4/5 times 3/3, what you'll get is 12/15. Okay, now for 2/3, to get a common denominator of 15, you'd have to times it by 5/5 to get 15 on the denominator. And what we'll get is 10/15. Then for 1, all you have to do is multiply by 15/15 to get a common denominator of 15. So what you'll get is 15/15. Now what we can do here is just multiply each of these terms by 15, because 15 times 12, and then you divide it by 15, so you cancel out the 15. So you'll just be left with the numerators of 12, 10 and 15. Alright, so let's do another example, but this time it will involve a little bit more problem solving, okay? So this question, we have two rectangles, P and Q, and we're told that the length of P is 50 centimeters. And then we're told that the length of Q is 20% more than the length of P, and the area of Q is 10% less than the area of P. So these two statements here, well, these are clues that tell you that you can make equations relating different variables for P and Q, so you're comparing both, and we can work out the different variables from that. So we're asked to work out the ratio x colon y, okay? So let's deal with the first statement about the length, okay? So the first thing that we can say is that the length of Q, QL, is equal to 1.2 multiplied by the length of P, okay? So PL. And this 1.2 is simply 120% written in decimal form because we're told that it's 20% more than the length of P, okay? So we can sub in what we know to figure this out. We can say QL is equal to 1.2 times the length of P, which is 50 centimeters. And this will come down to 60 centimeters. Okay, so we figured this bit out. Now let's move on to the second aspect, which is the areas. So we work out the areas, expressions for the areas of P and the area of Q. So let's start with the area of Q. So we have QA. And the area of a rectangle is length times breadth, so we have QL times QB. And we can sub in what we know, so QL, we just figured it out as 60 centimeters. And the breadth of Q is Y, so we're timesing it by Y. So this means that QA, the area of Q, is equal to 60 Y centimeter squared. So we've got an expression for the area of Q. Now let's get an expression for the area of P. So we have PA is equal to the length times breadth, so PL times PB, and we can sub in what we know. So we know that the length of P is 50 centimeters and the breadth of P is X. Okay, so this will come to the area of P is equal to 50x centimeter squared. Now we can do a similar relation to what we've done before with the lengths, okay? So what we can say is that the area of Q is equal to 0.9 of the area of P, and this 0.9 is simply 90% written in decimal form because we're told that the area of Q is 10% less than the area of P, so less than 100%. So we sub in what we know. We know that QA is 60Y, and that is equal to 0.9 times the area of P, which we've figured it out as 50x. So this will come down to 60y is equal to 45x. Now I'm going to write it in a different form. I'm going to write the x first, okay? So 45x is equal to 60y. Now let's get into the form. We have 1 is equal to 1x is equal to something, okay? So what we have to do is divide by 45 on each side. Okay, divide by 45. So 45 divided by 45, well that'll just be x. And 60 divided by 45, well that'll be 4/3. We just put that into a calculator, as it's a calculator paper. So we can say that we have, for every 1x, we have 4/3 of y. And that's the final answer. And finally, we'll finish all with an example that's as hard as it gets, okay? So this question is stating that Rana sells 192 cakes in the ratio small, medium and large, 7, 6, 11. And the profit for one medium cake is twice the profit for one small cake. The profit for one large cake is 3 times the profit for one small cake. And her total profit is £532.48. We're tasked with working out the profit for one small cake. So this is admittedly more complicated than the examples we've just done. So let's break this down. What we can see is that we've got two totals mentioned, which is 192 cakes and £532.48 profit. So the first ratio that we've got here is the total number of cakes, so the split of the number of cakes for the different sizes we have. Then we're going to deal with another ratio, which is the profit for each of the different sizes of cake, okay? So the first thing that we're going to do is deal with the first ratio, which is the number of cakes. So we're going to find out how many of each cake there is, Okay, so we're going to use a similar method that we looked into the part 1 video, which is a shading splits in a ratio. So the first step is to add up the different numbers in the ratio. So what you're doing is you're adding the total number of parts you're shading between. So 7 plus 6 plus 11 is equal to 24. Okay, then the second step is to divide the total number, which in this case will be the 192 cakes, by the total number of parts you're shading between, which is the 24. And when you calculate that, you'll get 8. Now the third step is to write the ratio out, and then we're going to multiply the ratio by 8 to figure out how many of each cake there is. So we've got 7, 6, then we've got 11 here. So we're going to multiply it by 8. So 7 times 8 is 56, 6 times 8 is 48, and then 11 times 8 is 88. So this ratio tells us how many of each size of cake there is. And if you're confused if you've done this right, what you can do is check it by adding these numbers up, 56 plus 48 plus 88. And what you should find is that you'll still get 192. Okay, so let's move on to the second ratio, which is a profit ratio. So what you can see is we have two statements here, and this is a clue that tells us that we can make different relationships with an expression containing the small cake variable, because the small cake variable is mentioned in both statements. We're going to write two different equations down. So the first equation that we're going to write is about one medium cake is twice the profit of one small cake. So 1m is equal to 2s. Okay, then we'll move on to the second statement. The profit of one large cake is equal to the profit 3 times the profit of one small cake. Okay, so at this stage what we can do is write another ratio down talking about the profits, but now we can replace the variables medium and large with expressions of small cake. Okay, so what we'll have small, we'll have medium, and then we'll have large, but we can replace them. So we've got just 1 here for our small, then we can replace medium with 2 and large with 3. So we've got a ratio talking about the profits. Okay, now what we're going to do is multiply the number of cakes ratio by the profit ratio. So write that down. We've got 56, 48 and 88, and we're going to multiply each of these by the ratio. So this is a bit that people will find confusing. Okay, so 56 times 1 is 56, then we got 96, and then we got 264. There we go. Now at this stage what we're going to do is something similar to what we did at the beginning. We're going to use the shading splits in a ratio method. So the first step is to add up the total number of parts that we're shading between. So 56 plus 96 plus 264. We calculate that, what you'll get is 416. And then part 2 is when you'll do 532 pounds 48 divided by 416. So you're dividing the total by the total number of parts that you're shading between. And what you'll get is £1.28. So what we have to do is now go back to the profit ratio and multiply £1.28 by each of these numbers. But what we are asked is to find the profit of one cake. So here we're going to do £1.28 times 1, the 1 coming from here, and the answer is just simply £1.28. Oh, so that's quite a complicated example. So that's us finished for today on ratios. So in the next video I'll be moving on to the related topic of proportion, so check that video out next. And if this video has helped you, please do like and subscribe, and I'll see you in the next video.